Oh, hello there. How's everybody doing? Hoping everybody's being able to stay safe. I'm Mr. Keeps, and in this video today, we're going to take a look at my latest project called MrBreaker. If you follow me on Instagram, you might have seen that I am working on this switch breaker tool. It's built upon previous work by Don, the guy behind the Board podcast. So I built upon this excellent idea of his. So I'll link the original project and to Don's video about it on the description. So the first thing we're going to need is 7 of those switch rails. And the next thing we're going to do is insert switches on each one of those. Like that. And then I already prepared the other 7. And you can see that I have the last rail here attached to this weight. So I'm going to go ahead and put switches here as well. So once you have all the switches added, we're going to add some keycaps to the switches. And in this case, I'm going to be using some blank DSA keycaps. I'm going to leave the link in the description for where I got those. They are very, very cheap. And the reason I have them like that is because I use lube on them. So they are a little bit dirty, if you will. So we need to go ahead and add keycaps for all the switches. And finally, we add the keycaps to this last rail here. The next thing I like to do is to add a little bit of this PTFE liquid lube to each of the keys. Just a drop is fine. This helps a lot. Also avoids having those keycaps being worn out over time. Now we have this other part here that is also supported by some weights in my case. And this is our motor holder. And this is the last piece of this machine, which comprises of this motor here that is a 12 volts, 95 RPM motor. I found this a good trade-off in terms of speed and torque. And now we're gonna connect this main structure to the rails we have underneath and make that secure like so. So you can see that now some of the keys are pressed and some of the keys are not. And that's for the first rail down there. So we're going to start assembling the other rails like so, pressing them till they get really tight and locked in place. And we're going to continue doing so for all of the rails. The next piece here is this controller box that takes a 12 volts, 1 amp or so power supply. And it has 2 other inputs here that I used some JST connectors for. 2 pins JST connectors. And if you open here, you can see the insides. I'm not gonna go into a lot of details right now, but this is what it looks like from inside. And this is the power supply I will be using. And I bought this one locally, but you can see that it's 12 volts, 2 amps, right? So I'm gonna plug this in. And you can see that this is booting up. And when it boots up, I already know the IP address that it is connected to. So I opened the UI on my phone, as you can see here. So let's go ahead and hook this up to the motor. So as you can see here, I have one of the ends of the JST connector. And this one is painted in black in my case. And you can see that I also painted this guy here in black, so I know that it needs to be connected here. And then I'm gonna connect the motor. It really doesn't matter how you connect it here. Either way is fine. It's just going to change the direction that the motors run. And another piece that I have here is one of those KO sockets, right? And the other end also has this JST connector, and this is for counting the key presses. So you can put it on any of the switches. I'm going to put it on this one here. Let me give you a close-up of that. So basically I will be plugging this JST connector to that switch over there, like so. And now I'm going to do the same thing here and plug the JST connector here, blue with blue. And now you can see that when I click start here, the motor will start running. And as you can see, the presses are being counted as the switches are pressed. So if I come back here and click, for instance, the minus here, the speed will decrease. And I can increase it as well, like that. And if I click stop, it stops. And I also can start a program, for instance, like, and then I can select the length of this program. In this case, let's do 1,000 cycles. And I'm going to click start. And as you can see here, the presses are being counted. We have how long this program has ran so far, my current presses per minute, and the amount that this is projected to take. This is the outstanding time, like the estimated time to complete the program, and it gets adjusted every so often. Now the RPM picked up a little bit. And you can, of course, stop it. You can resume it. And if you want to stop the program, you can click reset and then everything stops. Another thing you can do is use the API. So if you already know the IP of your box, you can do things like getting status from the tool, like so. So if I, for instance, start running from the UI, you can hear that it's running. But if I come here and I do the same stats, you see that it was clicked 20 times, the switch. The current RPM is 120. It's running on the backwards direction and this current speed is 10. Another thing you can do is trigger a program. So you're going to do a post to the IP, to the program endpoint, and you're going to pass the length as a JSON body. Let's do it a length of 10 clicks. And you can see that it started, it did 10 clicks, and then it auto stopped because the program just completed. So if you look at the UI right now and you refresh it, you see no program running. But if I do the same post again for 10 clicks, you see that the UI auto updates, and now program of 10 presses finished in 2 seconds. Let's do the same thing for 100 clicks, just so it takes longer. So you can see that the UI auto updates, even though I'm triggering the start of this program from the API. That's another nice feature of this. So it's saying that it's going to take another 9 seconds. And as soon as it hits 100, it auto stops and it gives you the message that it took 24 seconds.